Welcome to the live session on the gear and gear unit design theory and practice. This is a 8-week course, already almost 7 weeks are over, and today I am here to answer your question. So, first of all, I will respond to the question which was raised during the week wise the course session. Already we have answered those, but still I prefer that I will explain something more here. Next B, which is through the Google Sheet, and finally, what will be asked, what will be raised in this interactive session. Now, during the coursework, the first question was which I received. I have kept the question intact what it was. So, where is in a note of interrogation, somewhere is note of interrogation is not there, you have to understand of your own. So, first of all, why interference does not occur in case of cycloidal curve? This is very good question. Okay. Now, in true sense, both cycloidal and involute profiles are the locus of a fixed point on a circle which is rolling on another fixed circle. Now, here I would say for the involute, the rolling circle radius is infinity. This means that a circle, a straight line is rotating on a circle, on the periphery of a circle. Okay. Whereas, on the other hand, for cycloidal, the rolling circle is usually smaller than the fixed circle, and the point is on rolling circle, and the locus of that point on that circle, which is called, we may call it describing circle, the profile will be epicycloid. Now, if we roll that same circle inside the circle, this means that we are, say this is the circle, if we, this is describing circle, and if we take the circle rolling on it, the locus of this point will be cycloid, epicycloid, and if we roll this circle, then the same point, the curve, if we take the same point or other point of the fixed circle, here that will be hypocycloid. Okay. Combining these two gives the cycloidal tooth. On the other hand, involute tooth is generated by the rolling circle, which is a straight line and the point is here. So, this gives the involute. Now, we cannot rotate the rolling circle in case of involute inside that. So, if we try to do that, there will be undercut, which is called interference, undercut interference. Okay. So, that is why there will be interference. In case of cycloidal, this will not happen. This profile will be something like this on the describing circle. Okay. So, there will be no interference. However, there is a phenomena which is called cronode or double point. So, if we want to have a closed form cycloid, sometimes it will happen that it will cut the curve itself. So, at the time of generation, that double point or cronode will come. So, that we have to accept, but we use the cycloidal portion, only small portion of the cycloidal curve. So, in case of the cycloidal profile, there will be no interference. If you need further clarification, I welcome, you can send a message to me, I will definitely respond. Now, so here the next question was, I want to know about the torque written in specification page of bike for a Bajaj Discover 13 Newton meter. It is the torque which is required to move the vehicle including driver or it is the last gear torque. Now, here you have not, I think you should see this properly. There it is written either net torque or gross torque. Normally, it is written in the form the net torque a value at a PS which is power at certain RPM. Okay. Now, PS stands for this is a German word Fahrdienststärke. Phi will remain silent. That value is 1 PS is equal to 0.9862 horsepower, which is equal to 735.6 watt metric watt. Okay. So, that means that is the net torque, and at that net torque will and the power net power is what PS is written and some RPM. Now, that will be further converted, it will be multiplied, or it sometimes I do not know this what the mechanism is, that even if that torque is reduced while it is going to the wheel. Okay. So, there is a gearbox and changing the gear we can do it, and in case of there is no gear, then the clutch will be engaged and whatever torque required to drive that one, that will be consumed, rest of the torque will not be generated. This means that maybe that by controlling the fluid you can fuel, you can save some power. Okay. So, I think you have got the answer. However, if you would like to learn more, you can consult a book, as well as now it is available in the website. Say for example, I have given one here just to find out the best answer. I was knowing that, but still to find the best answer I consulted this website. You can consult that one and you can learn more. Now, third question was, I want to ask that when gears are transmitting the power through gear, the point of contact always changes the radial distance from center of rotation. So, while calculating the torque, which distance we should consider? Now, this is also a good question. Actually, you need not consider that radius. Simply, when a gear is cut, when a standard module is selected, teeth numbers are selected, then and pressure angles are selected, then the base circle is fixed. Now, two gears meeting means the line of action will be tangent to two base circles, that is the line of actions. So, therefore, the contact point will move on that line. Now, if you consider the normal load, that normal load multiplied by the base circle radius, that is the torque. Okay. Now, if this point come to the pitch point, let us consider only single contact is there. Then considering this per gear, what will be there? That pitch circle radius into cos alpha is the base circle, and you can read it. If you then multiply the normal force into P shear into cos of that angle, that will give the tangential force at pitch point and the P shear, pitch circle radius. Now, if we consider the helical gear, then a cos of that component will come there, that you will find in the formula. You can, I think if you see it, you can find that forces, and you will understand that while the point is still changing, the torque will remain same, it will not change. What you can do, if you take that radius as a vector and that normal force is another vector, then vector multiplication will yield the same torque wherever the contact positions. Okay. I think it is clear to you, but another a relevant question may arise. Now, while we are calculating the gear, as if we are considering the tooth are only one pair, and as well the tooth are at the top. Now, the tooth first will act at the tip, it will act usually at the tip of gear, because pinion is the driver. So, it is something like that. If you look into this, say this is the gear teeth and this is the pinion teeth and this is the line of action. So, contact first at the tip of that. So, probably we would better design the gears. Okay. But at the same time we should remember there is another pair in contact. So, that is also sharing some load, but for the safety or everywhere we consider the life will be infinity. In that way, considering the tooth is coming at the tip and only on one teeth, we design the gear. Okay. Now, if you really optimize the size, in that case you have to consider the how much really load is being taken by one teeth. FEM is one method where it is automatically calculated if you can properly assign the boundary conditions and others. You may read also some paper on the load sharing, there are few. Okay. So, if necessary you can write to me, I will give you the sources. Now, next question, while designing the spar gear or any other gear in certain books, they compare beam strength and wear strength and then design the gear on the basis of less value. If beam strength is less, then module of the gear is found on the basis of beam strength, and if wear strength is less, module is found on the basis of wear strength. So, I want to ask whether it is right, if not, then what is the right method for the same? Please explain. Now, I would say the methods are same. If you look in little different way, then these methods are same. Only thing, those who are selecting the way you have written, that is their material is fixed, they will not go for heat treatment. Okay. So, what they are doing, they in which case failure may come, that they are examining and they are taking the module in the same way accordingly. But in normal design cases, it is like that you might be allowed to go for heat treatment. So, what you can do, first you try to find out on the basis of beam strength, and usually you will find that failure occurs due to the contact stresses. You know perhaps that failure due to bending stress is that there will be crack, whereas failure due to the contact stress will be pitting, and normally you will find that gears are failed due to that pitting. The reason is that the design is made in such a way that it is slightly over designed. If it is there is no question of optimization, general purpose industrial gears, those are designed for infinite life, you can say. So, once they can take the bending load even with the dynamic load, then it will not fail, normally not fail, unless it reaches the alternative load, that is the fatigue, they reach the fatigue point, and these are not usual. On the other hand, the fatigue at the contact will occur, because it is touching and leaving, touching and leaving. So, you will find ultimately when the gears are rejected, there are small pittings over the surface. Okay. Now, in industrial design, what we do, we take a material, or we may consider the material later on. First, we from the bending strength point of view, we find out the module, then we verify what the state of the material, whether that is capable of taking the wear load also. If you find that it cannot take, there are several ways. You can increase the module, you can increase the surface strength by heat treatment, you can change the width a little bit so that distributed load becomes less on the teeth, so and so. So, that is why both methods are same, but the method here you have explained for the material is fixed and you are not going to for the heat treatment, and then you are calculating the module. Okay. Now, question 5, in week 2 lecture number 2 you have gave the formula to calculate the module at so this is 21.03 maybe page number, using the velocity factor and the number of teeth. The velocity factor CV will be calculated using the pitch line velocity, then the module is calculated, then the module rounded to the nearest standard value, and then no teeth, number of teeth will be used to calculate the pitch diameter. If we can calculate the pitch diameter only after calculating the module, can you please explain how to calculate the pitch line velocity to use in the module calculation? First of all, we need the pitch diameter to calculate the pitch line velocity, right. Only then we will be able to calculate module. So, this actually while I delivering the lecture, at some point definitely I have clarified that you cannot get all the data, you have to assess, because this is design, you have to take your own decision, width factor you are selecting, many things are selecting. So, CV factor usually at the beginning these are assumed, even you can start with that CV factor 1, then in after first calculation you will get some diameter, with that you calculate the CV factor and put again, you will find that module has changed. Okay. May change, may not change, because after first calculation you have assumed some standard module. Okay. On that basis you may find this is cleared. If it is not clear, so that you can modify that module. Suppose you got the module 3 after first calculation, assume CV factor 1. The next, after putting module is equal to 2.5 or 3, sorry, module is equal to 3, what the velocity you have got for that CV factor is such that it is coming the 3.2 module. Next, you have to take a decision. You can go for 3.5 directly, or else you can increase the width a little bit, or a material if possible, material strength. Usually later if you find you are heat treating, the strength will automatically increase. So, maybe you can compromise with T without changing any other data, or else you can go for 3.5. This perhaps I have mentioned somewhere in the lecture, I cannot find, I have delivered so many lectures. However, in the end of I think week 6, the last lecture, you will find there also I have mentioned this. Okay. I hope now I am clear. Now, question 6, why worm gear is have to be made of phosphorus bronze? What is the fact behind this? Now, while you must have learned that by this time, that in the worm gear I have shown how it is being transformed from straight spur to helical, 90-degree helical, then worm gear. So, in the worm gear, the helix angle, if you think of the which is worm, it is taken in other way. We consider the pitch angle. Okay. So, this angle becomes such that if you consider that the helix angle of the pinion, that will be that pitch angle 90-degree minus pitch angle, which is very high. And for that much inclination, there will be too much sliding motion. That is why the efficiency of worm gear is less. Efficiency is worm gear is very less. It might be 85%, 90% or even less, 80%. That is all due to that friction. Now, if we would like to reduce the coefficient of friction, then in that case what we have to do? We have to take such a material. Now, phosphorus bronze is a good material. Now, you may ask that if we take the phosphorus bronze, then definitely its yield strength everything is less. Yes, that is true, but if you think in other way that actual that is formative number of teeth, one gear means it is one teeth. Say suppose single start one gear worn means it is single teeth pinion, but if you divide by the cos cube of the 90 degree minus pitch, that will be a good number. So, there you will find these teeth is having the formative this form factor is high, and it can take high load also as well. Okay. So, in that way if you can go for say steel, but in that way the losses will be more, but the size may be small. So, you have to compromise with that. Using the phosphorus bronze you will gain ultimately, because your loss running loss will be less. Okay. It might be phosphorus bronze or some other material which is having less strength. I would say that this is one point. This is on the gear, we are using on the gear, but pinion is made of steel. Okay. So, that formative number which I am talking about, the pinion, that is having certain strength or sufficient strength, and as well as this worm will have also, worm wheel will have also sufficient strength. And another thing, if you notice that these teeth are made carved there, you can see a picture which I have shown. This means that it is going for larger contact. That means, load will be distributed over the worm wheel teeth. With steel worm wheel, obviously strength size will be less, but with phosphorus bronze it will all right. How to find sliding velocity of contact point? This is also a good point, but you have not clarified what velocity. Contact point velocity, which directions? If you think of line of action, easily you can calculate omega into r, that is shown at the first two lectures. But if you would like to calculate sliding contact velocity, then what you have to calculate that. So, between two contact points you have to find out the what is the length of the involute tooth here, what is the length of involute for both the gears. Okay. And then if you differentiate with respect to time, you will find the relative velocity, and that will give the sliding velocity. It is not very easy, but I would say a little tedious, but not difficult as well. So, you can try in that way. Say for a particular angle of rotations, you know how much involute teeth it has travelled on the involute path, then you have to calculate, integrate that path. You can take small angles, you can integrate what is the length and what is the time, you know, because you know omega, and differentiate it, you will find two velocity of this contact point on gear teeth and pinion teeth, and then you can find out a relative sliding velocity. Now, next question is that in module 3 lecture 12, you have told that if stage ratio is taken as 6 and 6.5, the distance between two sets of gear will be high. So, if we choose 4.76 and 8.19, the distance will be reduced and the size of gearbox will be optimum. I have perhaps maybe by mistake I have told it will be optimum, but it is like that. For optimum, you may not find that the ratio, if the ratio are made very close, it started with like that. Suppose the total ratio is 6 into 6.5. So, one may be tempted that if you take the square root, whatever the value is coming, if it is less than 6, we will take for both, or even slightly more than 6, we will take it more. But there will be two problems. First of all, with a simple example I have shown here that how it can be reduced size, not optimum. Optimum word if I have used, I am excused. Optimum you have to go to the optimization tool and you will find. But take this example 6 and 6.5. So, first stage whether it is 6 into 6.5 or 4.76 into 8.19, first stage module will be same. So, again if you would like to calculate the center distance roughly, you can compare like this, because the transmission ratio is 6 means a pinion sum teeth number and on gear it is 6 times more. So, you can take 1 plus 6 into say module has become 3 by 2. So, it is coming 10.5 and second stage definitely it is first stage reduction is high, second stage torque is high. So, for that perhaps module will come 4 and in that case 1 plus 6.5 into 4 by 2 is 15. Now, next if we consider 4.76 and 8.19, then we will find that 1 plus 4.76 into 3 by 2 is 8.64, which is less than 10.5 by almost 1.8 or so, something like that. And but next stage the torque multiplied torque is less, because first stage reduction ratio is 1 plus 8.19 and module perhaps you can settle with 3.5 and you will find that has become 16. So, 16 plus 8.64 and if you compare 15 into 10.5, in second case it is less. So, center distance will be less, maybe overall gear size, gearbox size may be same, because the second stage gear is big. Okay. So, this is just a thumb rule I talked about you. But another issue is there. If you come to the gearbox, then if you take the transmission ratio very close in first stage and second stage, here of course, we have taken, but sometimes what will happen, this gear this gear will come very close to the shaft, and if not the say modules are satisfied, but due to the size of the gear and size of the shaft they are perhaps fouling. So, you have to take care this factor. The best design is that here about 10 millimeter gap. You have selected the gear size is that cannot be found out, that cannot be automatically found out. You have to design the gearbox and then you have to see, maybe 2-3 trials will be required, or you can use an optimization tool by which you can find that. Okay. Now, can you mesh gear with different modules? Answer is no, you cannot, because the circular pitch, that means one gap plus one tooth thickness is equal to pi into m. Now, this pi m, if those are different, then either tooth will not go in, okay. It actually this will happen, the teeth will not go in, even if tooth is thinner, but it will got struck somewhere. So, the simple answer is that we cannot do it. Okay. Now, here this response to question raised through Google Sheet. Can you give assignment 3 in simple way? This is a faculty, he has asked simple way. This, as far I remember, assignment 3 means we have calculated a gear, we have designed a gear, that design is shown. Now, in that problem it is many things are clarified, and as we are going for the multiple choice question and answer, because the number of students is very high, it is 3500. So, checking assignments of 3500 was not possible for us. So, what we have done, this same problem which the gear design problem which we are designing, that we have put in a different way. Question data we have changed, and the question has been put in such a way with solution. If one make all solutions, he will be able to answer each question, he will be able to choose the right answer. So, that is why it is given in that way. I do not know simple means what you mean. You can write to me, I will definitely interact with you through email. Now, next question is that this course should have also include topics related to bearing lubrications, and in future why don't you teach us about analyzing gear failures and bearing failure. This is also I understand, because you are a senior design engineer. So, definitely you will think of this. Now, first thing, this course I offered this mainly targeting the BTech students who want to learn about machine design and who are not in the institutes where this course has a good safe. It happens, it is I am not blaming the institutes, I am not blaming the students, but it happens they may not get sufficient knowledge, may not gather sufficient knowledge through the teaching. So, targeting them I have shown this, as well as if an engineer from an industry, if he is there, then at least he will be find out whether I am going in the correct direction, at least he will be given some idea how to approach a design. Okay. But definitely if we would like really become an expert in the design of gears, then we have to consider bearing lubrications, failure of bearings, which I should premature failure of bearing and the failure of gears, but that cannot be taught without considering the dynamics of gears or vibration of gears. Okay. So, if there is a scope, then definitely I will offer a course in that direction also. Of course, I am not a man of dynamics and vibrations, but definitely I can give a course on how the gear fails and how the lubrication fails, how the bearing fails. Definitely it is possible, but again the possibility of launching such course is less, because very few people will be interested. However, if you are interested, you can write to me. I will try to help you giving some references. Can you give us more clarity about the exams? Are all the questions going to be multiple choice, which will mean it does not matter how you solve the questions, the only thing that matter is the final answers? I would say yes. Answer is yes. All question will be multiple choice as in assignments, but definitely looking into the all level of the students all, I do not know yet. What I have done, the questions are made simpler than assignment. However, you have to, there will be questions, I think there are 4 groups. It is like that, one group the question is simply yes or no. If you know this, you can immediately answer. Okay. Another is that is also yes or no pattern, but a small calculation may be required to do it. Now, there are next stage questions, there are calculation slightly harder than this, and last group it is you have to go for design calculation, which you have already taught through this assignment and the lectures, and that part will be slightly difficult. However, the first part you can answer, suppose it is a 3 hours, so I think first 3 part you can answer within half an hour. So, 2.5 hours you can spend on solving the problem and answering other questions. Okay. And definitely it will not be very hard, and also I take this opportunity to tell you that there is that gear drawing etc., that will not definitely come there, because there cannot have any the multiple choice questions, only few about the dimensions or different the shape and other things. A few questions might be there which is mainly concept based and general knowledge based. Okay. I have taught that nothing is outside the syllabus. And if you think, I think already week 7 is over, 7, 8 is coming. So, there will be you may find a little difficult in 7, which is with gear corrections etc., and the module 8, the last module, there are the machine tool gearbox and some special gear units. I think you will be able to understand, but taking all these, you may feel that exam will be difficult. One thing I can assure, from the week 7 and week 8 lectures, question will be very simple, very simple. Only you should clear your concept. If you have your concept clear, then you will be able to answer those, right. But remember, all are multiple choice, yes, no or multiple choice, and fill up the blank. That means it is like that. Suppose I have asked given a center distance, teeth number, and then I have asked you to calculate what might be the helix angle. Okay. If you consider the spar gear, say only straight tooth spar gear, in that case center distance will be less than if you provide helix angle, right. So, I have given the center distance, teeth number, module. So, you have to calculate the helix angle. Now, helix angle in your calculator, it is coming 11.53 degree. There it might be, it is written in form of degree, minute, second, that you must be able to calculate, and then a correct answer you have to put in that blank. Now, you should remember, there no scope of giving this symbol you cannot enter. So, you have to choose one result and you have to put yes, you have to put tick, say it is in the B, it is something like that, but there again the range is given. So, if it is say 11 degree 50 minute 20 seconds, instead of if you write 11 degree 49 minute 30 seconds, suppose, still that answer will get full score, because there is a range is given, unless it is very away from the actual result. So, do not worry about this part, keep your own confidence and try to answer. If you have learned something, if your conceptual concept has become clear about the gear design, that is my award, that will be my award. Okay. So, this is of course from a student. Now, next question, can you give us more clarity about the, okay, I have given this, how the gear will change. This really I could not follow. Question 4 is, this question was not properly uploaded. One faculty, Mr. Vijay Kothanandaram, really I could not follow I tried, but only one word, not even full word, it is a meaningless word came there. So, you can again write to me, I will answer to that. And question 5 is that how the gear will change, what does it mean? Are you talking about the change gearbox in automobile? That I have not taught here, only machine tools I have shown. In case of machine tools, but that is week 8, perhaps you have not yet taught. So, what do you mean here? Change in automobile gearbox. In automobile gearbox, first of all you have to decouple the shaft which is rotating, all it should not have any torque. It might be slightly rotating, but there should not have any torque. That means, it is disengaged by the clutch. Then the gear that will be pushed, those are maybe helical gear, but there is a synchronous. So, it will be first synchronized, and then if you push the gears, it will automatically go inside. So, as it is a slight helix angle, so it will first touch and then it will go. Are you asking that? If it is different, then please again write to me, I will answer. Okay. And now I can respond to the raised question during live session, but unfortunately what I find, there is no question. Something is coming over there. Okay, please wait. Now, this question is that how the gear change continuous motion. Again, what does it mean? The gear change continuous motion. What do you mean by change here? What it is changing? Gear, what it is changing? Are you talking about the shifting of gears with one ratio to other ratio, or you are asking that transferring the continuous motion? Really, I could not follow the question. You can if you are in the live session, again you can rewrite what exactly you mean. You can write few more sentence with that. So, the question live session, what I got it, again I cannot understand, it is the same thing. So, please you write more, do not hesitate, you write to me through NPTEL, or you know my email ID, you can write, just write that question from NPTEL on gear and gear design, so that I do not delete. I get many emails every day, do not hesitate. Okay. And I think there are no more questions. So, I wish you all the best. I find that 3500 students started, but only registration and examinations are few. It might be few of the other people they took to revise their knowledge, and other may be little afraid of writing examination. But I rest assured that examination will not be very difficult. I know the level of students. So, it is targeted all the good students, definitely they will score high. And suppose if there is some mistake in our part, definitely we will take care of that, do not worry about that. And one assignment we made a mistakes, that of course that had been clarified, and now if some wrong questions come, we will take care of that. That means, you will not lose any marks due to our mistake, that you should remember. There we will find some way. Sir, please explain the gear law. Now, again what do you mean by gear law? Are you talking about the this which we presented in I think week 2 lectures? That is mainly the gears are used for transmitting the torque or transmitting power, so to say. It is transmitting motion as well as transmitting the torque, and mostly it is used for increasing the torque, decreasing the speed. The reason is that the prime mover usually designed of a optimum size to make it, so it will transmit the lower torque at higher speed, but at the utilization end we need high torque at low speed. So, we need the gearboxes. Okay. Now, gearing law should be such that if the suppose the prime mover is giving a continuous speed, that means there is no fluctuation of the speed within. Not only, say suppose if we mean 1500 revolution per minute, this means the velocity is fixed or angular speed is fixed, and we are transmitting 1500 rpm. Okay. And utilization end also we need that, or even it is something different, still we are trying to transmit through that. So, first law is that we have to design the gear in such a way that it should be able to transmit 1:1 transmission is there. So, therefore, targeting that, the gearing law is shown in that. So, please go through that, you will be able to understand. It is like that, you will find that both the pinion and gear, they are having a common component on the line of actions. It should be like that, but the component in the transfer direction is different. That will give you the sliding velocity. Someone asking the question, so that sliding velocity you can calculate from that part also. And next another question, what is the physical significance of module? Now, this I would say the physical significance of the module is that if you can think in that way. So, this number or millimeter in this case, it has been standardized so that we can make some standard gears. Okay. So, here the module means that module into pi will give the arc distance, which will again the half the gap and half the solid portion, that is the tooth thickness at pitch circle. Because when I explained that you can transmit the motion assigning on two belt pulley, two curves, involute curves, you can transmit the motion. But to maintain the continuity, you have to put the same involute curve at an constant interval, equal interval, okay? And then that should be such a size that one when being disengaged, at least another is engaged. For that you have to find some size. Now, module has been selected in that way, for which at the pitch circle, one when the two wheel are mating, you can find out that pitch circle, the intersection of the line of action and intersection of the line of action and the line joining two centers. Okay. At that point, if you consider the standard, not corrected, consider the tooth thickness, because you may need to rotate in the opposite direction. So, there will be tooth, only not a curve, single curve. The tooth thickness there and the gap thickness are equal, and that is equal to the arc thickness is equal to pi into m. That is the significance of module. Okay. Sir, where are we attend workshop for gear? You want to learn that how the gears are cut and gear. So, one is that you can visit any gear manufacturing industry, there you can find that how the gear is being cut. Okay. If your gear manufacturing company is not nearby, you may find small companies who are also manufacturing gears for that. Usually everywhere, every industry, even if big gear industries are not there, there are small industries who are manufacturing gears for and supplying to the customers. Say this is usually not making large gears, but small gear units. So, I think you will be able to find that. You can go there, you can take their permission and you can observe how this gear is being cut. And usually in engineering colleges and universities, you will find the mostly second year workshop level gear cut is shown, but may not be in all institute gear cutting machines are there. Okay. Now, another question, in examination hall design data book is provided or not? No, no design data book is available there, but in the questions all data are given. So, you will not need any separate design data book for your examinations. You can, I think, if I do not know also what the examination, either you have to put on a sheet or maybe on the computer keyboard you have to type. So, you should take care when you are pressing say enter, that you should take care, but you have to move your cursor to the right circle and put enter. It will be something like that, and everything it will come on the screen, all data which you require, but you have to calculate. Probably there will be a page for rough calculation will be given. You need to have your calculator with you, okay, by which you can calculate and then you can put it there. Of course, some formula you have to remember, whether it is all the formula are not given there. So, that formula you can remember. This is in our Indian system what is there. Okay. I think we have finished, but I really do not know whether you are allowed to take the suppose printed lecture note which I have delivered. I will inquire with the people here. In fact, I do not have an objection. You can carry those note with you. So, if necessary you can see the note and you can calculate. Okay. But whether that is allowed in the total system, I do not know, that I need to ask. So, I think I find there is no other question. So, I end it here. I hope that you have been benefited through this course, and I will appreciate not only your suggestion, but also criticism, so that I can improve myself if there is another scope of delivering such lectures. And I wish you all the best and wish your success in the examinations or elsewhere if you apply this knowledge for really designing a gearbox. So, if there is no other questions, I finish it here and thank you.